Okay, for your quest set number 6, it gives you a crane holding a weight, and it tells you the length of that arm, and it gives you the angle that is inclined on, and it gives you the weight of this, and it wants to know the torque applied. So again, your torque is force times your radius times the sine of the angle between them. For those of you that were not in class, that's what we talked about today, was that sine of the angle thing. Now the issue with this question is that the angle that they give you is here, but the angle you need is the one that is made between your force and your radial arm. So if I extend the radial arm out like this is the angle I need, which if I do some geometry and draw a line that is parallel to this line down here, so I have this line is parallel to that line, then this angle and this angle are the same. This is 90 degrees, so this full angle that I need to plug in right there is the angle they give me in the problem plus 90. And you need to make sure your calculator is in degrees when you do that. And when you do that, that gives you the maximum torque for that particular problem. Now for number 7, which is the second part of number 6, it asks you, it gives you the same crane, so you have the same situation. This time it gives you a different angle. You have the same radius. This time you want to know what is that maximum weight that you can apply at this new angle. Well, in this case, the maximum torque that you have doesn't change for this system, because the maximum torque is the torque required to keep this from falling over. So that maximum torque is the same. So the maximum torque is whatever your answer to number 6 was. So once you get your answer to number 6, that's your maximum torque, and you know that your maximum torque equals the maximum force times the radius times the sine of your angle. And again, you have to do the same thing with your angle, where that angle is, sorry about the bell ringing while I'm recording this, the angle is the theta they give you plus 90, just like it was on number 6. And then number 8. Number 8 gives you a rod with a certain radius r, and you have something wrapped around it like a string, and then hanging off that string is a bucket with a mass, and it gives you that radius. And then you also have attached to this another r or crank with a different radius. We'll call that RC, and we'll call this RB, so the radius of the bucket thing, the radius of the crank. And this time it's asking you for the force required, the minimum force required. Well, the minimum force required to make this turn is going to be one where the torque that you apply to the crank equals the torque caused by the bucket. So there is a force from this bucket, and there's the radius here of the bucket. So force times radius is going to give you the force of the bucket times the radius of the bar the bucket's on, has to equal the force that you apply to the crank times the radius of the crank. Now the force that you're looking for is this one, and this force right here is the weight of the bucket, which is simply m times g. So then you would simply plug in m times g in right there, and you would end up with an equation that would look like your force applied to the crank times the radius of the crank equals the mass of the bucket times G times the radius of the rod that the bucket is hanging on. Then of course you simply divide by the radius of the crank to figure out your force applied to the crank.